Section 4.2, Permutations and Combinations, Video 2. In this video, we will cover the following objective. Calculate combinations. Suppose a person plays a game in which they must guess the arrangement of three numbers taken from the group of numbers 1, 2, 3, and 4. How many different arrangements are possible? This is an example of a permutation of 4 items taken 3 at a time. It can be solved using the formula for permutations presented earlier in this section. So recall the formula to calculate the number of permutations of 4 letters taken 3 at a time is 4 factorial divided by the quantity 4 minus 3 factorial. In other words, 4 factorial divided by 1 factorial, which ends up being 24. So there are 24 different permutations of 3 of these numbers, or 4 of these numbers taken 3 at a time. And these 24 permutations can be written out and represented visually. You'll see here that we have the 24 permutations listed, and each permutation contains 3 numbers. With a permutation, we have an ordered arrangement of items in which no item is used more than once in the arrangement, and the order is important. Now, suppose that to win the game, a person must only identify the correct 3 numbers without regard to order. So in other words, the grouping 1, 2, 3 is the same as 1, 3, 2, etc. It would be easier to win this game because a person would only need to select the correct 3 numbers without worrying about how they are ordered. In this case, there would only be 4 possibilities represented by the 4 columns in the list of numbers above. So here, the arrangements involving the numbers 1, 2, and 3 would be considered the first combination. So I'm going to abbreviate combination number 1. The set of groupings containing the numbers 1, 2, and 4 would count as this next combination. So I'll call that combination number 2. The groupings containing the numbers 1, 3, and 4 would count as the next combination. I'll call it number 3. And then lastly, the groupings containing the numbers 2, 3, and 4 would count as its own combination. I'll call that combination number 4. A combination, so this brings us to the definition. A combination is a way in which a set number of items can be chosen from a group. In a combination, no item is used more than once in the grouping, and the order of the items is not important. We will use this example to develop the formula for calculating a combination. We will start with the fact that we had 24 permutations, and if we visually displayed them, each column contains 6 possibilities that represent one single combination. The 6 possibilities consist of possible arrangements of 3 numbers. So if we look at the number of possible arrangements of 3 numbers, that's where this comes in. Notice that there are 6 in each of these columns. And how we can get that value of 6 is notice that we are arranging 3 different numbers. So there would be 3 different values that could fill the first spot, which would leave 2 values that could fill the next spot, and then 1 value left over to fill the last spot. And that is the same thing as 3 factorial. So each of these groupings contain 6 options, which is the same thing as 3 factorial. And so the 4 combinations can be calculated by taking these 24 permutations and dividing by the 6 arrangements in each grouping. In each group or in each column. The 24 permutations were found using the permutation formula for 4 items taken 3 at a time. And the 6 arrangements in each group, as shown above, is calculated 3 factorial. The permutation formula for 4 items taken 3 at a time was shown up above. That was 4 factorial divided by the quantity 4 minus 3 factorial, and then we're dividing that by 3 factorial. This simplifies, so if we clean this up, that would give 4 factorial divided by the quantity 4 minus 3 factorial times 3 factorial. And this demonstrates how to calculate 4 combinations, or how to calculate the number of combinations of 4 items taken 3 at a time. When order is not important, the number of ways to group these 3 items from a collection of 4 is a combination. And the number of combinations of 4 numbers taken 3 at a time can be represented using C and then in parentheses 4, 3 or 4C3. That's the symbolic representation. In general, the number of combinations of R items taken from a collection of N items is symbolized as C in parentheses N, R or NCR. And we just looked at an example of selecting groups of 3 numbers from a list of 4 numbers in order to develop the formula for combinations. And this can be generalized as follows. The number of combinations of R items taken from a collection of N items is N factorial divided by the quantity N minus R factorial times R factorial. Example 4, use the combination formula to calculate the following. Part A, 10C4. According to the formula, we will take 10 factorial, and then we will divide that by the quantity 10 minus 4 factorial times 4 factorial. This gives 10 factorial divided by 6 factorial times 4 factorial. Notice here, if I add 6 and 4, I get 10. So you will see that pattern there. Notice that this is similar to the permutation formula. The permutation formula would not have the extra 4 factorial in the denominator. It would look like that. So the combination formula involves 1 extra factor in the denominator. Now, if we want to write this out, we could write 10 factorial as the product of the integers from 10 all the way down to 1. Same thing in the denominator. 6 factorial would be the product of the integers from 6 down to 1. And then we would multiply that by 4 factorial, which is the product of integers from 4 down through 1. We can write this in a shorthand way, or to shorten up the calculation. 10 factorial can be represented as 10 times 9 times 8 times 7 times 6. Instead of continuing on, I'm just going to write 6 factorial. That implies that I would continue on down through 1. In the denominator, we have a 6 factorial times 4 factorial. We can simplify by canceling 6 down through 1. So in other words, 6 factorial from the numerator and from the denominator, which would leave us with 10 times 9 times 8 times 7 in the numerator, and then 4 factorial, which is 4 times 3 times 2 times 1 in the denominator. And this would give 5,040 divided by 24, which is 210. So there are 210 combinations of 10 items taken 4 at a time. Part B, C 7, 7. So we would take 7 factorial and we would divide that by the quantity 7 minus 7 factorial times 7 factorial. This gives 7 factorial divided by 0 factorial times 7 factorial. Again, notice that if I add 0 and 7, I get 7. So you would see that pattern there. Recall that as a special case, 0 factorial is equal to 1. So we really have 7 factorial divided by 1 times 7 factorial, which is just 7 factorial divided by 7 factorial. The numerator would be the product of the integers from 7 down to 1, and the denominator would be the product of the integers from 7 down to 1. And so the answer would be 1. The number of combinations of 7 items taken 7 at a time is just 1. That would just be the one combination involving all 7 of the 7 items. Example 5. To play a lottery game, a person must select 5 numbers from the numbers 1 through 50. Numbers cannot be repeated, and the order of selection does not matter. In how many ways can the numbers be selected for this lotto? Since this is an arrangement of, or since in this problem we are trying to find the number of groups of 5 numbers from a list of 50 numbers, and since numbers cannot be repeated when we are selecting them, and because the order of selection does not matter, this is an example of a combination. We have 50 numbers, and we are selecting 5. So this would be C 50, 5. The combination formula says that we would take 50 factorial, divide by the quantity 50 minus 5 factorial, and then multiply that by 5 factorial. This would give 50 factorial divided by 45 factorial times 5 factorial. Again, notice that if I add 45 and 5, I get 50, so you can see that pattern there. Okay, 50 factorial is the product of the integers from 50 down to 1. And instead of writing every single one of these, I will stop at 45 factorial, implying that I would keep going. But this is just a shorthand way to write this so that I don't have to write every single one of these numbers in this product. In the denominator, I have a 45 factorial times a 5 factorial. Notice when simplifying, 45 down through 1 will cancel in the numerator and in the denominator. This will leave us with the product 50 times 49 times 48 times 47 times 46 divided by 5 factorial, which is 5 times 4 times 3 times 2 times 1. If we calculate the product in the numerator and then we calculate the product in the denominator and we divide, we would get an answer of 2,118,760. So that is the number of possible combinations of 5 numbers taken from a group of 50. This concludes example 5.